Example 5. Graphically, find whether the following pair of equations has no solution or unique solution or infinitely many solutions. And the given equations are 5x minus 8y plus 1 equal to 0 and 3x minus 24 by y plus 3 by 5 is equal to 0. So in the question they have given two equations and they want to check whether the given equations are having no solution or unique solution or infinitely many solutions. So for that, what we have to do? We have to see when compared to standard form of equations, what will be the a1, b1, c1 and a2, b2, c2 values, and we want to find a1 by a2, b1 by b2 and c1 by c2. Then we have to see what is the relationship established between their coefficients. That is, if a1 by a2 which is not equal to b1 by b2, then we can consider the given equations as a consistent pair of equations. If a1 by a2 which is equal to b1 by b2 and which is not equal to c1 by c2, then we can say that these two line equations are having a unique solution. If a1 by a2 is equal to b1 by b2 which is equal to c1 by c2, then we can consider this pair of equations as coincident equations. That is, it has infinitely many solutions. Okay. Now, I think the second equation is in the fraction format. So I want to make it in the normal form by multiplying it with 5 by 3. So if I want to multiply the second equation with 5 by 3, then I am getting 5x minus 8y plus 1 equal to 0. So this is equal to the first equation which was given in the question. So that is, the lines represented by the equations 1 and 2 are coincident. We cannot finding here the coefficients and we are not comparing the a1 by a2, b1 by b2 and c1 by c2 values. We are seeing these two equations itself and we are concluding that these two line equations are said to be coincident. Why? Because these two line equations are same. So if you plot the two line equations, same line equations in a graph, so it can clearly resembles a single equation and it can clearly states the two line equations are coincident. Therefore, equation 1 and 2 have infinitely many solutions. So if you want to verify, check plot a graph by using some points for these two equations. These two equations as itself, these are same, so it can always be a coincident line. Okay. Example 6. Champa went to a sale to purchase some pants and skirts. When her friends asked her how many of each she had brought, she answered, the number of skirts is 2 less than the twice the number of pants purchased. Also, the number of skirts is 4 less than 4 times the number of pants purchased. Help your friends to find how many pants and skirts Champa brought. So, in the given question, what the information they provide? They provide information based on two conditions. That is, the number of skirts is 2 less than twice the number of pants purchased. Also, the number of skirts is 4 less than the 4 times the number of pants purchased. So, based on these two conditions, we have to frame two equations and we want to solve the two equations further in order to plot the graphical representation of the two line equations. Okay. So, let us consider the number of pants which is represented by P is X, purchased is X, and the number of skirts which she purchased is treated as Y. Now, so from the given conditions, now we have to find the equation. The number of skirts is 2 less than twice the number of pants purchased. So the number of skirts, that is Y, which is equal to 2 less than twice the number of pants purchased. If total pants is X, then twice the pants, that is 2 into X minus 2. See how I frame this equation. the number of skirts, that is we can represent it with y. So I am taking y is equal to 2 less than, from where 2 less than, twice the number of pants purchased. So here they are saying 2 less than, twice the number of pants. So I am treating pants, number of pants purchased as x. So 2 into x minus 2. So I can frame this equation as 1. Now, second condition, the number of skirts is 4 less than 4 times the number of pants purchased. So again, number of skirts denoted by y, which is equal to 4 less than, from where 4 times the number of pants. So if I am treating number of pants purchased as x, then I can write equation as 4x minus 4. See, this is treated as equation 2. How can I frame this equation? The number of skirts which is appended with y, which is equal to 4 less than, from where 4 times the number of pants. So 4 times, so 4 into, I can treat a number of pants as x, so 4x minus 4. Okay. So these are the two equations, and we want to solve further in order to get the values of the two equations to be represented in a graph. Okay. Now, let us denote the number of pants, and we have framed equations up to so far. Okay. Now, if I want to represent graphically, I want to find the coordinates of the points for these two equations. So the first equation, y is equal to 2x minus 2. So if I take x as 2, I am getting y as 2. And if I take x as 2, x as 0, and if I substitute the value of 0 in the equation, y is equal to 2x minus 2, I am getting y value as minus 2. Okay. Similarly, for our second equation, if I am taking x value as 0, then I am getting y is equal to 4, minus 4. Why? Because 4 into 0, which is equal to 0, remaining minus 4. And if I taking x is equal to 1, and I substitute x is equal to 1 in the equation y is equal to 4x minus 4, I am getting 4 into 1, which is equal to 4, 4 minus 4, that is resultant 0. So I am getting the points as 2, 2 and 0, minus 2. Similarly, 0, minus 4 and 1, 0 for these two equations. Now I want to plot these 4 points in a single graph, and I want to see what is the relation they have obtained. So after plotting the graph, we can clearly see that these two line equations are intersect at a point, that is q 1, 0. That is the line passing through them, which is intersecting at 1, 0. So this is the common point for both the line equations, y is equal to 2x minus 2 and y is equal to 4x minus 4. Hence, we can treat the value of x as x is equal to 1 and y is equal to 0. So, if we can clearly say that if the two line equations are said to be intersecting at any point, then we can say that these two line equations are said to be consistent, and that is a1 by a2, which is not equal to b1 by b2. Okay. Now, based on this coincident point, we can say that x is the value that representing the number of pants, and y is the value that representing number of skirts. So we can clearly say that the number of pants she brought is 1 and the number of skirts she bought is 0. That is, she didn't buy any skirt. Oh.